Hello, now I'm gonna present question 1. This is the question for question 1. Then after using the Microsoft Excel, I able to get this form. The provided sample mean is x equal to 22.325 and the sample size is n equal 8. Hypothesis. This is hypothesis that I can get from this question. Rejection region HO if T bigger than 1.8950. Test statistic T equal -2.0594. Then the p-value is 0.0392. So decision and conclusion I can get, because T equal to -2.0594, it's less than 1.8950. T value is not in the rejection region, therefore do not reject HO.
Okay, now I'm going to present for problem 2. This is the question for problem 2 and also included the data. So after using the aid from Microsoft Excel, I'm able to come out with this table of data analysis. So it helped me to do the hypothesis test step by step. The first step is we're going to do is the hypothesis. As you can see from the question, it said that average price of brand A is higher than brand B, which means the H null is the average price of brand A is lower or equal than brand B. The next step, we're going to do the decision rule or the rejection region. As you can see from the table, it said that T critical values of one tail that is 2.718. So it means we're going to reject H null if the T value is higher than 2.718. The next step is we're going to do the test statistic or the test value. As you can see from the table, the value came out as 0.4515. So now we can make our decision, which is the T is not in the rejection region, so we do not reject H null. So as for the result, we cannot support the alternative because there is no enough evidence to say that the average price of brand A is higher than brand B. Thank you.
Hi, my name is Sharifah. So I'm going to solve the problem 3. So they are given confidence level is 0.1 and we have to find the p-value approach. Before we want to find the p-value, we have to find the differences for this problem. So they are given 5 sample size and we have to before minus after to find the differences. So the answer is 0, -1, 0, 0, and -1.1. So for the mean, we use this kind of method, average, click all the data value from differences. Same goes to standard deviation. We use this formal bar and click all the data values from differences. For the value statistic, how we want to find the value statistic, we use -0.42 divide by 0.57 square root by 5, which is called sample size, and we got -1.630. So for the p-value, we use this method, click data analysis, and t-test paired 2 sample for means, click OK. For the variable 1 range, we put the data from before, and variable 2 range, we put data from after. So alpha, how we want to find the alpha is 100 minus 10, and we got 90%. Now we got 90 and divide by 90%, and we change to decimal, we got 0.9, and we click OK to get this result. Okay, from the p-value, we have to use the this formula bar, and for this 1.63, we have to use the t-test, which is this data, and divide by differences, a different level, a different, which is sample size n minus 1, we got 4 here, this one, and we divide by 4 and we got 0.1784. That what we call p-value. The answer for this kind of method, it failed to reject the hypothesis. Thank you.
Hi, my name is MAIKAL. So I'm going to explain how to do question 4 by using Excel. So firstly, you need to write table based on the question to the Excel. And then you need to click data and find data analysis. So you need to make sure is that got data analysis or not in your laptop. And then after that, after you click the data analysis, you need to find ANOVA single factor, because based on this question, the question 1 we use the ANOVA single factor. After that, you need to click and you click OK. So after you click OK, it will appear like this. So for input range, you just need to click all of the data or based on the table like this, and then it's automatically copied to the input range. And then you need to click label in first row, because based on the table, the first row is the brain A, B, C, right? Okay. And for the alpha, you need to find alpha. So how to find alpha based on this question is, you know that the question gives 80 confidence levels. So you need to minus, so 100 minus 80, so equal to 20. So 20 divide by 100, so you get 0.2. So you need to write 0.2. After that, it's automatically give you the answer based on the ANOVA single factor. So based on this data, the answer by Excel, you will get the value is 0.010754. So that is from me. Thank you.
Okay, hi, for problem 5, I will show how to make the question A and question B. Okay, for question A, run a regression analysis using Microsoft Excel, and then propose a regression equation that can be used to predict number of sales by an employee. Okay, this is the table that I already provided for question 5, and then we go to data, and then we go to data analysis, and then we click regression, and then click OK. And then for input Y, we put our dependent variables, this part, and then input X is our independent variables, X1 and X2, and then we click label, and then we click output range. Before we click OK, we have to click a blank column to click OK. So we can get the result like this. And then for regression equation, okay, the number of sales by employee equal to 14.862, which is our intercept, and then plus 4.619 our X1, plus 4.315 our X2. Okay, for question B, interpret the coefficient value of each independent variable in the contrasted model. Okay, beta subset indicates that a unit increase in Xi will increase or decrease the value of Y by beta subset unit given independent variable remain constant. Okay, for beta 1 plus equal 4.619 implies that an increase in the number of years that an employee has been with the company will increase the number of sales by an employee by 4.619. Okay, for beta 2 equal for 4.315 implies that an increase in the number of years that an employee has been with the company will increase the number of sales by an employee by 4.315. Okay, that's all from me for question C. I will pass to my group members. Thank you.
For question number 5C, the first step we have to do is to set the hypothesis.
hypothesis beta 1 equals to 0 when there is no significant linear relationship, and beta 1 does not equals to 0 when there is a significant linear relationship. For step 2, we have to set the decision rule. Reject hypothesis if p-values equals or smaller than alpha, which is 0.05. Do not reject hypothesis if value equals or larger than alpha in the value of 0.05. Both x1 and x2 have the same hypothesis and the decision rule. Well, in step 3, we have to find the p-value. From the table, we knew that the p-value for x1 is 0.137551, while in x2, the p-value is equals to 0.13877. The decision we have made from x1 is by using p-value approach. Since the p-value equals to 0.137551 is larger than the alpha in 0.05, then we do not reject the hypothesis in 0. While in the x2, by using p-value approach, since the p-value equals to 0.13877 is larger than the alpha in the value of 0.05, then we do not reject the hypothesis too. And the conclusion we have made for x1, there is no significant linear relationship between x1 and the number of sales made by an employee. And the x2, in conclusion, there is no significant relationship between x2 and the number of sales made by an employee. Thank you.